The first major model we're going to be covering is that of the waterfall model. So with the waterfall model, what we're doing is we're basically waterfalling from step to step to step. So we start in the requirements, and then once we're sure the requirements are perfect, we move to the design. Then we move from there to the implementation once we're sure that's perfect, down to testing, down to deployment, down to maintenance. Now, this doesn't have to be, these steps. It can be any series of steps that get us to this final conclusion. But the importance of the waterfall method or the waterfall model is that we're moving from step to step to step. And it's sort of what we've been covering the whole course, how we're talking as if everything is in one linear flow and you always follow those steps. However, the problem with the waterfall model is that it isn't very adaptive. It's very, very predictive. Remember those two words we used in the last lecture. And because it's very, very predictive, it means that if we find errors, let's say in the testing phase, that means we're going to have to go backwards. So if, for example, we find it in the testing, let's switch the color right here, then we're going to actually have to go back to the implementation, and then from the implementation back to the design, and then requirements. And basically what we're going to have to do, let's say we find an error in here, a really serious error with the way we've programmed our software. We're going to have to go and change the requirements, fix the requirements. Then we're going to have to go fix the design. We're going to have to come up with new subsystem designs, new module designs, etc. Then we're going to have to go back into the implementation. We're going to have to recode it, and then we're going to have to retest it. And if the thing's already deployed, we have to go even farther. We have to keep going back and rework everything from there. And once we get to the maintenance phase, it's sort of like just in a circle down here. It's going to keep going. However, if we're making major changes in the maintenance phase, we still have to do the exact same thing. We're still going to have to keep going all the way back and redo everything to make sure that all the documentation and everything is supported within the waterfall model. So the waterfall model is one that is very, very, like I said, predictive. It is something where your team must have coded this before for it to be successful. Now with this, it is also very efficient and it is very simple to use. So there isn't a lot of overhead. So again, if you're creating multiple websites or something like that, then this model is probably something that is going to be good for your team because they don't have to spend a lot of time actually thinking about the software design process. They can use a process that's already been designed with a whole bunch of steps and they can just work with that. Now with the waterfall model, we also have this issue of this cost over time to fix. So let's say each of these are the different steps. So, this is once the requirements are finished, once the design is finished, once the implementation is finished, once all the testing is finished, once deployment is finished, and so on. Again, it can be different steps. But the importance of this graph is to show you that as you go farther, it isn't just this linear cost over time, meaning that, if we fix it, if we have to do something here, it's just all of this combined to get back to this point. It's this sort of exponential thing where if we make a mistake and we find out about it, maybe in the implementation or near the deployment phase, it's going to take us substantially more time than if we fixed it in the requirements phase, maybe up to 50 times the amount of time to go back and change everything to get it to work again. And because of that, the waterfall model is not flexible at all. Each step must be extremely well planned. We must basically make sure it's all perfect. And some corporations will do this, and it actually is very, very sort of, a lot of programmers will sit around and twiddle their thumbs waiting for the requirements or something to be passed through a whole bunch of different committees to make sure that it's perfect. And so there can be some time loss in there as well, but it needs to be extremely well planned. And it's going to take a while to get the product on the market. If we do something, which we're going to talk about later, something more iterative, where we sort of create a V1 that's really basic and we start adding features with V3 and version 4 and version 5, then we can get the product out really, really soon. And then from that, we can, start building onto it. And I don't know why, but a snowman sort of came to mind here. And we can actually get a product out that, sort of starts working for, that we can get feedback from, that we can beta test, that we can get money for. But with this, we're doing it all in one shot. The first version of the product is probably going to be the final version of the product. And because of that, we might actually miss our market opportunity. Maybe if we had gotten out, half as many features 3 months earlier, it would have been far more successful than being 3 months late with all the features. And something that's very important is that technology moves fast. And with this, we won't be able to adapt to new technology. So if we're in a fast developing field, like for example, cars, where, car software is really developing pretty quickly. Same with like Internet of Things software, like smartwatches or like smart shirts or whatever. That whole market is developing really fast, and new technologies are coming out 6, 8, maybe 1 year at a time. And so because of this sort of quick iteration, because of the yearly or maybe even like monthly iteration of technology, if we're building a piece of software that takes 2 years to build and we're not going to put out anything in between those 2 years, by the time we get our software out, the technology may have moved on and our entire project is obsolete. So we need to take that into account as well. But the waterfall model, because of all this, it's decently bad in a lot of areas, but it shouldn't be written off immediately. It does have its benefits in more organized structures and places where teams are creating the same things over and over. And it does have that efficient, low cost to run sort of idea with it. But this is the first model, the waterfall model. It's very important, and a lot of things are based off of it.